Good afternoon, everyone. I'm sorry. I promise you that I'll release the video today. It's 10:30, but there's no problem because finally now I'm releasing the video for projectile motion in 2 dimensions. Okay, in this case, then as I said, that we'll be dealing with the projectile in 2 dimensions. We have those things, those important things. We have the projectile, we have the trajectory, we have the free fall. On projectile, as we know from high school, uh, projectile is an object upon in which the only force acting on an object is the force of gravity. And then we come here on the trajectory. Trajectory is the path of the projectile and it has a parabolic shape. We know parabol from maths. Finally, we have the third definition, which is a free fall. Free fall, we have a free fall when the object is said to be in a free fall, when gravitational force is the only force acting on that object. Okay, and then here, guys, I gave you some examples. Let me start with this one, the projectile. On this one, we have the projectile. We have the velocity which is separated into two components. We have the x component and the y component. Then as we know that the x component is constant, so since the angle here is 0 because it's closed, it moves along the x axis, we have vy which moves along the y axis. We use v1 when we are doing the calculations from here, from point A to this point, which is point C, because this is point A, this is point B, and then this is point C. Point C is at maximum height. Point C is at maximum height exactly. It's at maximum height exactly. And then here we know that the final velocity is 0. As the object moves upward from point A to point C, its velocity is keep on decreasing, and then when it returns to the same starting point, the velocity keeps on increasing. Then this depends on the direction of your own that you chose to use. So in this case, I used the direction that said that upward is positive. That means everything that goes downwards is negative. Okay, then let me explain the trajectory. Okay, on the trajectory, there's nothing more to explain here, guys. It's a diagram which shows the path of the projectile motion. Okay, finally, we have the object, an example of the free fall. As I said, that a free fall is said to be, an object is said to be in a free fall when gravitational force is the only force acting on that object. So we know that this is the ball which is at rest. It's at rest because its initial velocity is 0. Then to do we have only one force that is acting on that object, which is the force of gravity. And then they give you the acceleration due to gravity, that's 89.8 meters per second squared. Okay, we have the projectile motion equations for 2 dimensions. It's still derived from the same equation that we use on kinematics in 1 dimension. As we know that these are the equations that we have for kinematics in 1 dimension. These are the equations. We have the first equation of motion, this one, v final is equal to v initial plus acceleration times t. Okay, then since we choose the direction that upward is positive, so due to that g, this is g, the acceleration due to gravity, which means in this case we'll use negative here. So we'll say that v final is equal to v initial minus, it's plus or minus at, and then we separate this velocity, initial velocity, into its component. So we know that we use the y component, which is v sine theta. So in this case, we'll substitute the v sine theta since we are dealing with the kinematics in 2 dimensions. Okay, and then we have this one. This is a change. We know that as I explained in kinematics in 1 dimension, that I have a displacement. The displacement is the shortest distance from the initial position to the final position. Okay, then in this case, as we know that this equation is supposed to be change in x is equal to v initial times t plus or minus 1 over 2 at square. And then they separated this x because they transpose x initial on the right hand side. And then now we have this derived equation. And then we also use this equation. Thank you. That's it for today.